Hi, I'm Tom and I talk about code. Welcome to another Rust programming live stream where today we're going to be doing even more work on my 16-bit virtual machine. This stream is going to be all about adding virtual hardware devices to my new web-based UI for it. This is going to be a device for doing text input and output, 1 byte at a time, the way God intended. And we're also going to do a virtual screen. I have a virtual screen that kind of works already, but I'm going to build a better virtual screen. And I'm going to use my newer interfaces to make it all just work a little bit better. So let's dive in and start doing some of this. But before we can do any of this stuff, there's one problem that has been plaguing all of the code that I've written all around this machine for a while, and that is that currently we can only load and store 2 bytes at a time. If we jump over to let me make sure I change off of the scene because I always forget to do this, to where the instructions are actually defined. We have a load instruction, we have a store instruction, but these both read and write 2 bytes at a time because they kind of work with registers, right? So when I implemented them, that made sense. We've got a register, we want to store the value of that register in memory, we want to read it back out, but when we start interfacing with other devices, they may not, for example, if we want to write a character to some kind of output stream that's mapped in, that's memory mapped, we probably only want to write 1 byte at a time. We don't want to do UTF-16. We don't want to repeat the mistakes that Microsoft had made in the past. So let's add 2 new instructions to our instruction set. Let's git status first and see what's going on here. Oh yeah, I had to do this, didn't I? So I fixed my problem from last stream. I'll show that in a second. It's not that exciting. Basically, I just worked out how to do WASM stuff. I've just got to clean up a little bit from what I had before. What else was I doing? VM signal. Oh right, all this signal handler stuff. I haven't committed any of this. Okay, well let's commit all of this. What branch am I on? Better UI. Yeah, this is part of the better UI. That's fine. Register source VM source WASM, and let's just commit these. Source better new signal handler. Oh, we need to add the bin as well, don't we? That's why this file changed, because my signal handler API has changed. These signal handlers are going to be important to what we're doing. We're going to be working intimately with this code, and I'm going to show it off in a sec. So commit new signal handler interface for better JS interrupt. And I can't spell. Actually, let's leave that for now. Okay. Oh, and I should also add cargo because cool. Because we had to add new dependency. Okay. Let's have a look at what it currently looks like. So this is the old interface. This thing freaking sucks. Test.html. This is the new interface, the new sleek interface, which isn't going to live at test.html forever. It's going to move to index.html imminently. But we can build this, and if I pull up the developer console and actually I'm correctly in tiling mode, hello. There we go. There we go. If I step through this, we're going to see, so first off, this this system instruction is set up to system call 1. This is kind of our system call, do something outside of the processor interface, the system instruction. This is to write whatever is in the register we give it. So we give it the number 5, it writes out the number 5, and then this F0 we've hooked up to do a couple of things. We can see that we read a couple of things out of memory, and we set the base pointer to 777. So that's kind of fun. And if we have a look at how that works over here, HTML rather. Nope, that's the wrong file. That's very much the wrong file. This is the right file. So all we do is we make a new action set because we have to have this kind of proxy. We do some stuff with it. We tell the machine to halt, and then we pass that back. Now that I'm done kind of testing it out, this is all I actually want it to do. All it should do is halt the virtual machine. But we're able to bind these JavaScript functions very naturally into our code, which is great, which is fantastic. And then we don't actually need to do anything here. What happens if I delete this? Do I get an error? Do I get an exception? when I run? Yeah, I do. Okay, so I've got to have an empty function here that just does nothing. That is something I should fix at some point. Anyway, I got very distracted from where I started. That's a brief tour of what we were just doing before, and now let's add a new instruction, a new op. Now hopefully this is going to be very simple because I did a lot of work with macros early on in these streams. Currently we only have 16 instructions, and we're going to bust out into these later opcodes and start doing some other stuff. So here we go, 10. We've rolled over a hexadecimal digit. We're going to have load byte, which is going to take a register and 3 registers, a destination, a address, and then a kind of page, or something which we all, with the base of the address, left shifted by 16 bits, which allows us to index a full 32-bit address space, which is kind of cool. But also you can just use 0. If you're not dealing with that much memory, you can just use 0. Okay, so 1, 1, we're gonna also have store byte. Now if I build this, it should give me a couple of errors, which is great. It's gonna tell us where we haven't matched these new instructions before. Is that it? Yeah, beautiful. Okay, let's do it. So match op, when we're actually implementing these instructions, their behaviors. Let's put them in here, instruction. Let's actually copy and paste, because this is gonna be very, very similar to load byte. So we read from memory, except now we're only gonna read 1 byte. And then we set the register. We'll have to say as U16, because this is only going to give us back a U8, an unsigned 8-bit number, I'm pretty sure. So that cast is going to be important, but also maybe not. We'll find out in a second. But yeah, the big thing is we want to make sure that we only we don't do too much work here. Because we don't actually know what reading and writing more than 1 byte is gonna mean, because of how devices can get mapped into our memory. Okay, that might be a little bit subtle. So then store, we're gonna do this. We're gonna mask it with just hex ff, and then we're gonna as u8. Cool. So if I build this, I forgot to put a u there. Excellent. Unreachable pattern. Store byte. Perfect. So that just builds. So all of the instruction encoding and decoding is automatically generated by way of all of the wonderful macros that I wrote. So that's very cool. That's really paying dividends here. I'm also just going to call this load word and store word, because I think that makes more sense. Now this is going to break some things. Store word, load byte, load word. This is definitely going to break more things. Here we go. So in our compiler, we have load and store. This is now load and store word. Load word. And that's it. That's everything. Cool. So if we build this, if we rerun it, we should just be able to run our examples. Everything's fine. That's beautiful. That is beautiful. Let's test out a new instruction. Let's write a store. Let's say, so after we write, after we just print out to the console, let's say let's write to hex 1000. That sounds like a good number. And we'll say store byte BA0. I think this should store the value of B at A. I'm pretty sure. If I build this out of range, what's this? What is this? That number was too big for what we can load in an immediate. Excellent. Okay, let's that number was too big. Let's write it to FF instead. And I don't really know what that did, which is kind of funny. I could attach some tracing memory to this. Our memory interface does let us kind of log all of our memory actions. That's not as interesting. Let's just go into where we have this. Let's do what we were doing before and say let, or not even let, let's just say vm.read memory, and we're gonna read address ff. We'll see what's there, and now vs console.log, this should print out whatever we have in that register. 0. So not quite. Not quite. This should store 5. Store byte. Okay, hold on. Load. So A becomes FF. And then we should store, but something happens here. This in fact appears to not be storing. This appears to be doing something else. So let's go back to our virtual machine and see what store byte is really doing here. Memory.write. Interesting. That's really weird because store byte appears to be defined correctly. Store byte. So we get R0, we get R1. Base 0, 1. Ah. Okay, that's not quite right then. So the value we write is, oh gosh, why did I do it this way? Why did I do it? Why I need to be much more consistent. So it's actually A0B. For some reason this modifies B, which is a bit concerning. That really doesn't feel right, does it? Nothing here should modify register B. So straight away we've got a problem. straight away something is severely wrong with this code. Oh, and it's really hard to see what that is. It's really hard because there's no set register here at all. Store byte. Okay, so here's something we can do. We could say store word, right? And build, and step over this and see what happens. And this is more correct. Huh. Okay. So store word, I mean, if I print this out, we can actually see this gives the expected value, which is weird because when I change it to store byte, it appears to just do something totally different. And it modifies B. 0, 1, 2. Get register R2. But we don't set a register. How is this possibly? It's like our But we can't print ln, can we? That is so strange. That is really strange. That is really, really strange. Let's just rebuild the WASM just to be sure, and then we'll run this again. And it still sets register B. Why would it be setting a register? Okay. Why would it be setting a register? A0B. Ah, hold on. There we go. That would be why. Add and save A0B. I suspect that I've done something very, very silly here. I suspect I've done something extremely silly. Yes, and that is I've already added 2 opcodes. These aren't sorted ascending. So these opcodes actually overlap with existing things. So this should be 1, 2 and 1, 3. And at some point I'm going to reorder these opcodes to make more sense, I think. Like load byte and load word maybe shouldn't just be like whatever random offset they happen to be. Maybe there should be some rhyme and reason here. I'll decide on some, AVI at some point. Due67T. Duty? Do I just call you Duty? Says hello, welcome to some fun Rust programming where things go wrong, and that's okay. Let's rebuild this. Let's rerun this. Excellent, it prints out 5. That's what we want to see. That is what we want to see. And B is not modified. So this is a case where having this little viewport here where I can see what instructions are being executed, it really, really paid off. Really, really paid off. Okay, so that's good news. And we can actually check this off of our thing already. So let's do exactly that. Load and store 1 byte at a time. Done. Check it off. Let's make that more of an obvious tick. Cool. Cool, cool, cool. Wonderful. Beautiful. Beautiful. Well, let's commit that as well. So add source bin. Let's just add everything in source. Instructions to load and store. Cool. Cool. So the first device I said I wanted to think about building was a text I/O device. And in my UI, I've called this a terminal output, which is a little bit jank. The idea is that you write numbers to this and they will correspond to characters in some kind of output area. So in other words, probably the simplest possible thing. And there's probably got to be a couple of different ways to control this device. You know, maybe we need a system to send it messages, right? Because we'll need to have some kind of display. Sorry, I'm just getting my tea sorted. I have to. Okay, I'm gonna have a very refreshing drink soon. Okay, so let's get a new page going and let's draw a rough design for what this is gonna be. So I've done the silly thing again where I need to set up pages in a complicated way. So what I want is on my page, right? So I've got, you know, my 2 columns. I've got the program here, and that has lines, and then one of these lines that we're currently executing is highlighted in red. So that's okay. I just closed the whole browser. That wasn't what I wanted at all. Local host. I have no idea. Oh. Well, just as well, I wasn't even showing it. Okay, perfect. So we have our 2 columns, right? And when the program's running, it looks like this. So there's the program view and then the VM control. And I think the output should go on this side, right? Maybe the very first thing up here will have some kind of new element. It'll just be, you know, a box. And as characters, well, and it'll like show characters. Let's say A, B, C, and then we'll have all the other stuff like the state of the registers and the instructions and all this other fun UI, and then the buttons that do things. These are wonderful buttons. Cool. So this is my mock-up. I hear there's a Figma conference on at the moment in San Francisco, and I really think they should have invited me. I don't know why they didn't invite me to talk. You know, that's all I'm saying. So we have a virtual machine running somewhere off in space, right? Somewhere in WASM land, we have a VM. And our VM has registers, which I'm going to call regs, in a very hard to read font. And we also have memory. And our memory consists of, you know, we'll kind of have our program mapped in here at some address. We'll have RAM, which is probably some much bigger area. So we'll call this P for program. We'll call this R for RAM. And there's no real limit to how many things we can map into memory. So we're going to map another thing into memory, and it's going to be quite small. And we're going to call it T for terminal. Or for text, I guess. And this is going to control this. So as we read and write to a certain part of memory, it's going to make characters appear and maybe disappear. I haven't really thought that far ahead yet. It might be a one-way stream, but maybe there'll be a backspace character. Maybe that's the trade-off. It would also be cool if you could write things. Maybe there'd be like 2 parts to it. So there'd be this. Let's call this out. No, I hate when I. Okay. Anyway, sorry. I'm wrestling the GIMP. Out. And would have an in with like a submit button. Go. And you could write hello. And hit go, and your program would somehow be able to interpret this, right? So it's a bidirectional, one character at a time stream. So what would this look like? What would this look like? This is a good question. My most simple model for what this could look like, and this is what I think I'm going to do, this terminal memory interface, it's going to be, let's call it address 1. Well, let's say the whole thing is at adder x, right? So that's at some offset in memory. So this is like x at offset. Let's say x, let's say write, if you write to, what is going on? If you write to x, show character, or append, I guess, add char to output, read x always gives back 0, and then write x plus 1 does nothing. Let's actually call it unit, right? Because it's just not a value. And then read next character in input, or 0 if no characters left, right? So 2 memory addresses, very clearly defined read and write semantics. Very, very clearly defined. So this is what we need. This is how we're going to implement this as our first pass. And I think this is gonna, and obviously, you know, these are gonna be ASCII characters. So we'll display, let's maybe make a note of that as well. Let's say note display as ASCII. My handwriting is shocking, but you get the idea. I think this is a solid design. I think this is a workable design. All right. Okay. We've got a very good philosophical question in the chat. Okay, this is a very important question. Really requires all of my attention. If Rust is Rust, then what language is Iron? I think Rust is Iron. I think C is Rust, right? You know, the language Rust is like shiny and new and strong, and then C is like weird old jank falling apart. Practical, right? You can use a rusty old tractor still, but it's rusty and it's old. That's my vibe. That's my vibe. What does that make Python? That makes Python its own beast. Python is a snake, right? It's vicious, it's efficient, but you don't want to get bitten by it. Okay, so let's just try and build this. I could think more about this, but let's just do it. Do I want to keep adding to this one file? Sure, that'll be okay. Well, actually no, let's make a new file and let's call it hardware.js. We're gonna make a class. We'll call it this is kind of like it feels kind of serially. Let's call it class text IO. Oh no, I apparently have autocomplete enabled, which is not something I ever want. I don't know why I have this on for JavaScript. Prof Element says you like virtual hardware, it's fun stuff. It's really fun. It's like building everything from the ground up without any of the concerns about like resistors and all that fun electronic stuff that I don't understand. Okay, so a text IO, when we build it, it doesn't need any arguments. We're just gonna say self this dot, we'll give it a buffer, which is gonna be empty string, and I think that's probably, and we'll have, or maybe out buffer, and then we'll have an in buffer, which is also going to be empty string. Okay, so then we're going to say write. We say this dot out buffer plus equals b. Can we do that? Can we plus equals a string in JavaScript? We'll find out. Judy, you don't know how to write code, but you watch people talk about it and read a lot about it. You should try writing some code. It's worth learning. It's worth learning. Everyone should learn how to write code. Everyone's capable of learning how to write code. You know, you just have to go for it. It takes a lot of work, but if you're already watching people and reading about it, yeah, just do it. Just bite the bullet. It's easy for me to say because I've been doing it for a very long time, but I think it's worth doing. I'm gonna actually double check this. JavaScript concat character to end of string ? Text member in list. Yeah, okay. I guess that works. I didn't think strings were mutable. I know you can't say like, you can't do this, I don't think, with JavaScript strings, but I guess this is okay. It probably allocates a new string under the hood. And then we're going to have a read method, which is going to say if this in buffer, if the length is greater than 0, then we want to grab out. It's going to be this dot in buffer the last character. We're going to say this dot in buffer equals is subster, wait, is subster deprecated? Deprecated. Whoa, that's insane. Substring, is this the same or does it have different semantics? Zilla. Wow. Okay, that's not that exciting, but it also kind of is. Buffer length. I think I want to do length -1, right? 2, 3. 0, 1, 2, 3. 0, 1, 2. Yeah, okay, I think that's right. This is a really inefficient way to do this. Don't do it like this, but just live with it. Cool. We'll wear that. Interesting. Interesting. Modzy Pumpus, are you a real person? This is a very bot-like comment. Judy, you know how to use Lilypond? Lilypond's really cool. I really want to learn it because I also do music. And yeah, it just seems like a good way. I like Latte, and I just should commit to Lilypond. This needs parentheses. Okay. Buffer, and then we just return out. Otherwise, return 0. Like I said, this is really inefficient. Don't do with strings like this, but whatever, it's okay. And when we write, I guess we maybe also want to say this dot render target. We'll just make it undefined for now. Maybe we won't. Nah, we'll detach this. We'll detach this. Or will we? I might have made this too specific. This dot, because we need to be able to bind this into memory, and we probably want to. I'm on the fence. Basically, the thing I'm thinking about right now is what does the interface to actually use this look like? Let's write an example, right, where we say bind and we take a VM, and we take an offset, which is the memory address we'll bind it to, right? So we'd say vm.map memory I've got to remind myself what the method's called, map memory func, right? Where we take, the start is offset, the size is 2, and then we have two functions, read, which takes an offset, and then write, which takes an address and a value. But these are relative to the offset that we give it. So we'll either get, the address will either be 0 or 1, basically, for this to be valid. You're thinking of learning Haskell because Haskell seems fun, seems like they need an 8th person to join their community. Haskell love new people to join their community, but if you're not a programmer already, Haskell is very obtuse. If you are a programmer already, Haskell is very obtuse. I would say learn something easier first, start with like Python, build up to Haskell. But Haskell is cool, and if you learn Haskell first, every other language will seem kind of stupid afterwards because you'll have so many tools that you're used to using that no other language has. Okay, so if address is 0, God, see this autocomplete? I'm fighting it, right? I hate this. I really need to turn this off. What did I say? I said x, read to x, gives 0. So this is our read function. We return 0. If address is 1, we return this dot read. Wait, I got this backwards. No, yeah, I didn't get this backwards. Read x plus 1. It's confusing. I've written these in a weird order. Okay, so our write function is going to be the same thing, where if adder equals 0, we write to this address, this dot write value. Except we kind of need to turn this to do turn value into a car. We need to turn this value into a character, which we can do. Otherwise, if address is 1, we do nothing. And let's add this final else as well, where we're gonna throw new exception, right out of bounds. We're gonna say the same thing down here. And I think this message gets thrown away anyway, but we'll throw it just because we can. Cool, so how do we turn a number into a character? JavaScript ASCII ORD into car. Beautiful, beautiful. How can we put an ASCII code into a character? String from car code. Of course, that makes a lot of sense. So let's go string.from car code value. In that instance, the autocomplete was useful, but I would still rather not have it. Excellent. So this is cool. This gives us a buffer. Now we need to actually use it somewhere, though. So this is where something, well, again, let's just do the stupidest thing we can. Render, let's say, render target. Actually, let's go document.create element, and let's make a div to put this in. Okay, this is gonna be fine. This is gonna be fine. Now when we write, we'll also this dot refresh. Oh crap! Am I meant to not? I'm not meant to do underscore case, am I? Oh shit, I left my bin out the front. I need to bring my, we had bin day. I didn't bring my bin in. I'm just gonna do this refactor very manually because I think it's good to have good style. I'm pretty sure this is how I'm meant to do JavaScript variables. Not that it matters, not that anyone's gonna come and like enforce this, but I'm just trying to be consistent. These function names come from Rust, so they're not consistent, which is annoying. It's very upsetting to me. In buffer. Okay, that looks good. We'll have refresh output with this method. Actually, let's put it up here. Refresh output, and this is just going to say this dot render target dot inner text is this dot out buffer. Cool. So what else do we need to do here? We need a way to get render target. I don't want the DOM object exposed. Literally, let's make it a P instead of a div. We'll deal with this. So then we can document.appendChild, or we can, element.appendChild, whatever our render target is, and then once we bind it to a VM, as we read and write, that thing will get automatically updated. Let's maybe call it get element. I don't know if that's a good name. I don't know. Names are hard. Names are really hard. Let me just also move chat back over here. That's cool. Nice. Out buffer, in buffer, render target. I'm missing something. Oh, I'm missing input. I don't know how I'm going to do input, and I'll think about that later. Let's just dump it in the page and see how it goes for now. Test HTML. We need to include script. That's just going to be from, what did I call it? Hardware.js. Cool. That feels good. And then we will we'll just dump it on the page. We'll just dump it on the page somewhere. That sounds nice. Reset VM, init VM. Here we go. So VM, bind handler, blah 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 blah. Let's put it in here. Let's say text IO. Bind to the virtual machine at address. Which address should we put this at? This is a good question. This is a really good question. How big is our memory? New VM. VM memory size. Map memory, VM memory. Oh yeah, right, VM memory size. So let's maybe say VM memory size plus 16. We'll just give it a nice little offset. This does make it hard to know. I guess it's not fixed. Let's maybe say hex. This is too big to do in a single instruction. That's okay. That's okay. Let's put it at E1000. Hex E1000, my favorite number. Okay, so new text O, bind it to the virtual machine. Except that's not where that goes. This is where that goes. E1000. Okay, and then we also need to say one of these elements. Let's call it VM. Where's a good place to put this? Where do we put this? Enable screen. This is all the other control. Let's say VM state. Let's const. We'll just grab this into a variable, VM state container dot hidden is false. This is bad JavaScript. Don't write JavaScript like this. Use a library like Vue or React that lets you do this without this kind of reactivity without all the stupidity. But that's okay. And then we'll just say VM state container append child get element. Okay, and this is going to work first time with no problems. Okay, it just didn't do anything, but that's that is also valid, I guess. We also have no namespacing here. It's fine. Don't worry about it. Don't worry about it. Let's see if this actually runs. Okay, it runs. That's good. That's pretty good. Oh yeah, of course it doesn't show anything, right? Let's... Yeah, obviously. So the reason nothing happens is because the out buffer has nothing in it. So let's write a program that writes something to E1000. Let's get rid of this. So let's go... What's the ASCII character code? I guess let's pick 61 as a number. Okay, so we'll load 61 into C. Is it hex 61? I'm pretty sure it isn't. Characters, number. What's 61? 61 is equals. Let's do 64. That's a funnier character. Oops. It's a much funnier character. Tate, I have already made this typo once today. Okay, so. What did I say? 64? I literally forgot what I was doing already. Okay. Now we're going to load B with EOO, hex EOO, and then we're going to shift left BB4, I think. Yes. Yes, okay. Cool. So shift B left by 4 and store the result in B. So now this is the address we want to write to. So now let's say store byte. And what order did these go in again? I think it went B0C. And then we'll get rid of this write, and then we hold with A. Okay, so let's step over this and see what happens. B is now... Five, 7, 3, 4, 4, 5. Oh yeah. 5, 7, 3, 4, 4. Excellent. That's the number we want to see. And now when we store this byte, we can see an @ symbol appears. So that's kind of cool. That's kind of cool. Let's go back to edit, right? Let's do this again. So let's do this differently. Let's set up this B register with this. Actually, let's use the M register, because M stands for memory. So C... let's write hello world really stupidly. Let's do the dumbest hello world anyone's ever seen. And this is going to be the first hello world I've actually done with this machine, which is kind of cool. H is hex 48. So let's do this. H. This is really dumb. 65. I need to remember E, then double L, so that's probably gonna be 76C. Curse my lousy base 10 brain. Let's just say hello for now. 6F. Nice. Okay, we're gonna go back. Oh no, we're not. We're gonna copy this. Oh, except these will need to be M's instead of B's. This text input, it would be really nice if this was a monospaced font as well, a mono font, because this is a little bit silly. Okay, we're gonna build it. We're gonna step. Hello. Wow. It took a long time to get here, but we're finally on the track to Hello World. Let's get rid of this one. Let's do it. Let's go the whole way to Hello World. So then we want, is it hex 32 or is it it's decimal 32? All right. So hex 20, right? Yeah, 20. So space. World. W-O-R-L-D. W, capital W, because we want to be proper, 57. O is going to be like, oh yeah, of course, 6F, we've already had it. R is going to be 7, 2. L is 6C, and then D is going to be like 6. Hold on. H is 65. So let's say 6, 1. Is that it? Let's copy this real quick and let's run it. Okay, I can't do math. 63. I still can't do math. 64. Here we go. Hello world. Hello world. Perfect. Now, obviously, it's a bit of a problem that we accumulate our trash here, right? This was a bit of an oversight in my design. And also, funnily enough, we're just going to keep pumping garbage out to the same one buffer. If we run this on a clean page, we just get this nice buffer that will infinitely fill up with hello world. Now, we obviously need to make this look a little nicer, right? We need to make it clearer that this is some kind of terminal output. We need to style it. Maybe it needs to be, actually, instead of a P, maybe it should be a pre, right? And maybe this should, be better nested inside something. Maybe we'll make something like the state. Maybe we'll come in here. Before all of this, we'll say div id equals VM output. And this is where we could put a canvas as well. We'll say hidden equals true. And then every time we go back to editing, we just nuke this div. We get rid of everything inside of it. That would work. Right? That sounds kind of cool. So let's say div id equal VM term. We'll put that inside its own div, and then we'll also have canvas container. Cool. Cool. So now let's go back to where we did this. We can actually undo this. Document.hidden equals false. And now we just want to say .bind document.get element by ID. And it's a, what did I call it? VM term container, right? VM term container. VM term container. Excellent. And now when we go back to reset VM, what did I call this? Did I call it stop VM? When I program stop document.get element by ID, VM, again, what did I call this? VM output. We just nuke the whole inner HTML. Something's gone wrong. Something's gone a little bit wrong. Step over this. So where's it going? Where's it? What's happened? What does our inspector say? Grid, this part of the grid, VM control, VM output, hidden true. What if I just unhide this? Does that fix my problem? It does. It obviously does. Yeah, cool. Now we have hello world in a much better output kind of looking situation. And we can reset this and run it again and run it again and run it again, and we get this one nice long hello world output, this kind of ticker output. Now, what else is cool is that I could go back here. Okay, well, so clearing it afterwards didn't work, and also it still persists when we go back to editing. That's okay. That's okay. But let's crank this clock speed down and then run it. We can see it kind of, let's crank it down even more. Let's go a 10 to the speed. If we run it, we can see it print out these letters one at a time, which is kind of fun and kind of whimsical, and I keep accidentally closing my tab. Cool. Okay, well thankfully I copied that. 6.4. We can build this, we can run this, and yeah, we can see the instructions go one at a time and print out a nice little message. First hello world of this machine. It's not a very smart hello world. I could do this in a loop instead, and I will once I do a bit more work on my programming language, but this is a good start. This is a really, really good start. Cool. So again, I've got my issues with this pattern. I've got a few things I could probably clean up here, but this is a good start. We need input as well. We need input as well. Maybe I do write a loop version of this that kind of like echoes. That would be fun. That'd be really fun. So let's say this dot read target. Maybe like this, and we'll say get output element, and then we'll maybe have a get input element. And then we'll get a button as well that actually reads, where we'll return document dot, or we'll say document dot create element. We'll make a button, we'll say b dot on click, we'll make it a function. We'll make it a, I think this is the kind of function we want so that we can still say this dot read target, oh this dot, sorry, in buffer dot inner, what am I saying, this dot, yeah, this dot in buffer equals this dot read target dot value. That's what I want. That's what I want. Right? Does that make sense? We just copy the in buffer into the thing we're reading. And maybe let's even say plus equals so that previous buffers aren't just eradicated. And then that puts it on the end. Is that right? No, because we read, because we read from the end. So we probably want to actually say this, because then we'll consume the previous buffer before. It's confusing, right? Right to left, left to right. It's just a thing. This would be more obvious if we were writing right to left. Okay. This is a weird blending of domains. I'm not happy with how my abstractions come out here, but I'll survive. VM output. Now I don't know why this hasn't just completely nuked the inside. Is it because I've misspelled inner HTML? Ah, get. Where's TO? Oops. Get output build run. Oh, I'm doing this very slowly. Let's just reset it, go back to editing. Let's build, and yeah, so now it's working. Now it's working. Get element by ID is null. Field term container. Oh right, hold on. Heh. I got rid of the thing that I needed. Okay, I'm gonna be very careful now to not close the tab, which is good. In HTML. In HTML equals 0. Okay, that's better. This now is gonna work for me. run, edit, build, run, edit, build, run. The output is cleared each time. That's a nice little tweak. Makes it a lot nicer. Makes it feel a bit better. Let's see if we can. Let's see if we can make it better. Let's see if we can make it better. So, oh dear. Oh dear. It's kind of hard. It's kind of hard, right? So let's do this. So we append the child here. I guess we also just append a child to this. We append get input element. I guess it isn't that hard actually. And then we just get, what do I call it? Get input button. And that's it. Where's the button? I'm guessing there's a argent1 is not an object. What did I do wrong? I didn't return B. There you go. That'll do it every time. Maybe call that send. This button styling is horrible. Maybe I actually make this A because my other buttons aren't actually buttons. They're, where are they? Role equal button. They are links with role equal button. B.attributes dot. Well, I think I can just do this, right? Role equals button. Pretty sure I can just do that. Let's find out. Maybe not. Okay. Foo. Oh, I wonder if I can loop forever, right? That's kind of fun. That's kind of a fun idea. So let's see if we can write a smarter program here. This is important, the M register, then we'll say loop in. So the start of our loop, we want to read M plus 1. So let's say, no, let's load 1 into register A. Let's add A MA. So A is now the result of M plus A. Actually, I'm going to run to the bathroom before I get too stuck into this. I'll be back in 1 second. Okay, we're writing some assembly. We're writing some low-level code. So the address that we read from is E1000, hex E1000, and then we have to... Oh no, sorry, we read from E1001, we write to E1000. We're going to keep E1000 in register M, and we're going to add one to it as needed to read. So let's try read byte. We haven't used read byte before. This is a brand new instruction. And we're going to read. Let's load byte. So register 0 gets the... I really need to think about what I'm doing here. Let's read it into A. Does that make sense? Maybe. Maybe we'll regret this. Read into A. So from address A, read that from memory into register A. So whatever character we get from the input. Now we need to test test A0 both. We add test instruction. It's a bit funny the way we do comparison, but basically we have a really easy way to test if two registers are both 0, and we can use that with the 0 register that's always 0 to easily test if the register is 0. This is one of these reduced instruction set concessions that I made to keep the number of operations small, which is cool if you ask me. Okay, so test if A is 0. Now, if A is 0, we want to do a conditional add. And again, this is how we branch. This is how we do local jumps. Conditionally add to the program counter. Again, now we need to think about how many. Let's just call this X for now. Okay. So if A is 0, we want to skip the part where we actually read something in. If A is 0, we don't read anything. Or if A is 0, sorry, we don't do anything with A. Because it's the end of input. So we're going to skip over this next instruction. This next instruction is where we're going to say, we're going to set the program counter to the label let's call it loop echo. Otherwise, we're going to jump to... Otherwise, we just jump back to loop in, and we loop forever. This is an infinite loop, okay? So we're going to add 2 to the program counter because this is multiplied by 2, which is very confusing and easy to get wrong. Okay, so now let's have our label loop echo. All we do now is store byte. We just store whatever's in A, store byte, there, and then in PC loop in, loop forever as well. Does this build? Probably. And then if we do happen to fall through, we do that. So if I build this, does it build? Yes, which is kind of cool. PC 18, this seems right, then we jump back. Okay. Let's see if we can step through this. So, straight off the bat, it says invalid instruction. Oh, probably because there was a compiler error. Read byte. Yeah, okay, sorry. That makes sense. Read byte, load byte, build. Okay, I think we're good. So what happens if I now say foo and I step? So we're running. We've actually compiled this time, which is good news. M is going to hold this address, which is where our terminal device is located. Then we're going to load that +1. Then we're going to load whatever comes from there. Now, our internal mapper has said this is not okay. Loading from this address, our internal mapper has blown up. So that's okay. We can deal with that. Let's see if this read actually comes through here. And let's just reload the whole page for now. Build. Oh, yep, hold on. I need to actually, what do I call this? Load byte. There we go. Now I build this and we're okay. Now I can step through. If we look back here. Okay, so we hit this, which is good news. Address is 1, which again is good news. We return this dot read. So let's step into read. The in buffer is 0. We return 0. And now, so this works this time for some reason. I'm not sure quite what the broken state was. Actually, I forgot to send anything. So let's try this again and let's say foo. And let's run. Now we get here. That's good. In buffer is foo, which is kind of cool. So out is going to be the last letter. Actually, I want to take from the head. I've done this backwards. That's okay. So where... Load by A0. Okay. So this is maybe not what I thought had happened. This is maybe not quite what I thought happened. Let's do another thing real quick. And actually preserve comments. Preserve labels, rather. Or not. That's okay. We don't need to preserve comments. Preserve labels. Bugger. I get that wrong every time. So we can set the in buffer. That's good news. You know what? Just while I think of it, let's actually do this in the correct order. So this is now just plus equals this. It does just go on the end. I'm very silly. We want to get the first character, and then we want the substring is just everything from character 1. Cool. So we build this, we load foo, now we step. Load byte. And now we get this internal map error. Okay, so this is actually happening here. So let's run again. Address is 0, but we're happy. We're very happy. This out is the letter O, which still isn't right. Oh, I guess because we already read one. Okay, yeah, so O is correct. And then this is just the letter B, which is cool, so we step over this. Everything seems okay. Now we're just into this land. Internal mapper error. I wonder what goes wrong here. So let's look at VM. WASM, internal map error. Wait, did I actually return anything? Did I remember to TIO? Did I remember to return? This is very important. Return this .read. Okay, so we did return something. That's worth checking. So this callback seems to be okay. Res. Okay, so we can JS error to string. So let's maybe say match. Oh, we don't even need to do this, do we? We can actually just say let res equal this dot map error, and we can say JS error to string. Except it's got to be memory Oh gosh, this is a long line. All these error lines are so long. Error, internal mapper error. Cool. And now this just gets question marked. All right. So does this build? I can't spell internal mapper error. G32 found string. Oh, except yeah, so this doesn't take a string. Let's maybe say invalid map instead, I guess. Invalid map. We'll take the address and we'll take a message. Oh no, sorry, that's also not right. Let's do this. Let's do this. Okay, perfect. Internal mapper with... The fact that I have error in the name here is a bit stupid. Cool. Let's try this. This is, it just gives us a bit more variant defined here. Oh, and I still got this wrong somehow. Okay, now it works. Now it works. Perfect. So now, hopefully, at least we will get more context with this. So we send this. Now, when we hit this load, result not a number. This is good news. Oh, and it's obvious, right? We're trying to read a number out of memory. But what am I actually giving back? If I thought about this for like 2 seconds, I think it's a sign I'm getting tired, right? Look at our read function. It gets the first character in a string, then just returns this. So I need the opposite of string from car code. String to car code. Can I do this? Car code at. Beautiful, beautiful. Car. And actually, in buffer.car code at 0. We don't even need to do the index, right? We just get the first character. Then we return out after we advance the buffer. Nice. Okay, so now this should work beautifully. We get character 102. Now if I look at my ASCII table that I closed the tab of, what is 102? 102, that is the letter F, so that's perfect. So this might actually just work. If we step, it outputs the letter F. Now we read again, we get the letter U, and if I run this, my tab is going to crash because it actually just goes too fast, which is very, very funny. Which is very, very funny. So let's crank this clock speed down a lot. Oh, except I need the correct program. I should really like put this somewhere, not just in my clipboard. This is valuable cargo. Okay, so foobar. Now we run this, we can see it step through, and it will hopefully just loop forever once it's done. This is kind of cool. I could raise the clock speed. I think this is actually going to pick up speed as we go. So this now loops forever. Hello world. I can send another message. I can queue up a couple of things that it should send. I accidentally queued this up twice. It would be nice if I could adjust the clock speed. If I had like a slider or something I could pull, I could just go like back and forward a bit, speed it up, slow it down. That would be nice. It would also be cool if I could halt on something happening, on interaction. But anyway, this works. This is a cool interface and this works. I think I might have to leave the screen for another day. I'm obviously getting a little bit tired. My focus is wandering a bit, but this has been so much fun. I've been looking forward to this point where I would get this extra interactivity. And yeah, it's been so good. It's been so good. All right. Now, we've got the wonderful option to raid someone, and it'd be good to throw some viewers over to someone doing something cool. If anyone has any good recommendations for cool software and game dev streams, or for any streams really, my friend Justin is streaming Diabolical Rogue. I could always throw some people towards him. That would be kind of funny. Here's a bunch of programmers here to watch you play FPS games. Oops. I love that the homepage of Twitch does that. Software and soft. And game development. Salton, hello, welcome. You are coming in right as I'm leaving, unfortunately. But, you know, these things happen. What have we got? 3D platformer. Web dev. ASMR programming, no talking. GPUs and Julia, that sounds cool. GPU stuff is very cool. There's me. Rust and Nvim. Total graphics. Let's do that. Uncle Scientist. We're gonna... Abe Simpson entering and leaving meme, yeah. It was a real banger of a stream. You should check out the VOD when I put it on YouTube. But we're gonna, yeah, throw some viewers over to Uncle Scientist, because that sounds cool. And yeah, thanks everyone for stopping and watching. It's been good fun. We've had some good results. You can see my machine is picking up speed for some reason. Let's just reset that for now. But yeah, it's been cool. We've got good results. It's all coming together. It's all looking more professional and slick, and it's only going to get better from here. So thank you so much. I will see you all next time. Let's go check out Uncle Scientist.